Alright guys, so let's continue. Let's see. Okay, so we left off at the equivalence property of logarithms instead of exponentials. So for this one, the equivalence property is kind of follow the exact same logic, it's just for logs. So it has the exact same setup. If b, x, y are real numbers, oops, and b is greater than 0 and does not equal 1. Yeah? Then, if log base b of x equals log base b of y, that means that x equals y. Yeah, so it's the same application, just instead of exponential, it's a log. So over here, I'm saying logarithm of base b, logarithm of base b on either side of the equality. Okay, and notice there's nothing else. So I don't have anything added, anything multiplied, nothing. Just the logs. Okay, so log base b here, log base b here. Exactly the same base on both sides of the equality. That means that the inside of the log, x and y, notice using different letters, that means they're not the same. That means x and y are equal. Okay, so let me show you an example, and hopefully it will be a bit more clear. Because again, just like the first one, this will help you solve equations involving logarithms without using the calculator, because if I give you x, your calculator is really not going to help you. Now, let's see. Let's start with log base 2, which is example number, question number 9 in the homework, on the notes, sorry. Okay, so it's log base 2 of 5x minus 1. So this is the left side. Equals, here's your right side. Log base 2 of 2x plus 17. Okay, so 5x minus 1, 2x plus 17. These are the insides of the log. That's why I use parentheses, because I want to include everything. Now, look here. We have two logs. They both have the base of 2, right? 2 and 2. That means it's exact same log, exact same base, which means these two cancel each other out. You end up with the insides. This directly means that it is 5x minus 1 equals 2x plus 17. See that? I grabbed this one and I grabbed that one. They're equal to each other. And now we solve for x. So I'm going to grab the 2x, move it to this side, grab the negative 1, and move to the opposite side. So this turns negative. 5x minus 2x equals, over here we have 17 plus 1, so it's 18. Over here we have 3x. Divide by 3, divide by 3, and x is 6. Done. Okay. Now, there's something I want you guys to do though. Unlike exponential functions, which are very smooth, you don't have to worry about the domain too much. When it comes to log, we do have some worries. So, there's a check step that I want you to do. Check. I want you to grab the answer and plug it into the question. Plug it in here. Okay? So you grab the 6 and plug it into the x, right? So over here we have what? Log base 2 of 5 times 6, which is 30, minus 1, 29. So it's log base 2 of 29. Yeah? On this side. 6 times the 2 is what? 12 plus 17, that's 29. So log base 2 of 29. Checks out. All good. Now the reason we did this isn't just to check the number 6 itself, it's to check that it doesn't ruin the log. Meaning that once I plugged it in, I'm not going to end up with a negative inside the log because you cannot have a negative value inside the log. Make sense? So that's why you check for it. If you check it, both sides, the logs are valid, and by valid I mean you can actually calculate this. If you're not sure just by looking at it, use your calculator, which is why I told you to have this one. So here's the button that allows you to choose a log to any base you want, like that. So once you press it, the first entry you do is going to be the base of the log. So since this question gave me base 2, I'm going to enter base 2. Press the arrow to move on to the next one, and now I'm going to enter the inside. So it's going to be 5 times, actually no, I'm just going to do the multiplication. 5 times 6, which is 30, minus the 1, which is 29, right? So log of 29 is 4.8579. And just to show you that's the same thing, just a 29, boom, same number. So it's calculable. You can calculate it. We're good. That's all I want you to check. Because as far as the answer is concerned, we already know they're going to be the same. We solved it. Make sense? And the reason you're doing this, because again, sometimes the log won't work out. So if the log doesn't work out, that means the answer you found isn't a valid answer. Therefore, you would just scratch it out. Now, if you had more than one answer, you'd lose one of them that didn't work. But if you only had the one, that means the question has no solution. Make sense? So check by plugging in. Okay? And again, when you plug in, you do it into the question. Because again, I'm going to give you a few questions where you have to do some work before you actually start solving. So the first line you use is going to be the question itself. You grab the answer and you go to the question that was typed onto the paper, not the first step after you start solving. Okay? Now, let's move on. It'll become a little clearer for you. So everybody copy this? I kept moving, I'm not sure. So let me pause for a few seconds so you can do that. Okay. Now, let's keep going. Okay. Here is the next example. In this one we have what? Log, no base. So when I write a log with no base, what base is that? 1, 2, 3. You guys should know the answer by now. It is base 10, right? No base is base 10. And when you see ln, that's base e. Okay. So now, log base 10 of x minus 7 equals log base 10 of 5 minus x. Alright, now let's solve this. We have base 10, same base. That means I can grab the insides and set them equal to each other, right? So it is x minus 7 equals 5 minus x. Yeah? Now we solve. So I'm going to solve for x. I'm moving the negative x to this side. It becomes positive. And I'm moving the negative 7 to that side and it turns positive. So over here we have 2x and over here we have 12. Divide by 2, x is 6 again. Now let's do our check. Okay, here we go. I'm plugging 6 in here. Now, x is 6 minus 7, total is 20. Oh, sorry, 20. Ugh. It's negative 1. 6 minus 7 is negative 1. That means you have log base 10 of negative 1. And what did I say about having a negative inside the log? See what happens. Error. There's no answer for this. So, since it doesn't work out, that means that this solution is not valid. But just to make sure, you can check the other one too. Log 5 minus 6 is also going to be negative 1. So, both sides don't work. But just for reference, in case you ever stumble across a problem where only one side didn't work, that still is no answer. Both have to work. Okay? So, since we plugged it in and it didn't work, that means It failed my check. This is not a solution, which means the question has no solution. Okay? It is unidentified. So there's no solution. There's no solution that gets this equality, because the only answer we had didn't work. Okay? I'm gonna write the next one while you guys copy this. I'm doing number 11 next. Okay, I'm going to go up now. So we have log, no base, so it's base 10. Now, log of 3x minus 4 minus log base 10, since there's no base, of x plus 1, yeah, equals log of 2. Okay, so this 2 is what's inside the log, not the base. And if it confuses you, always put the inside the log between parentheses. I find that helps. Yeah? So a common mistake I see is you're starting out with having a base for the log, and as you work the problem, you forget that the number you see here is a base and think it's multiplied, and it works its way into the inside of the log instead of being a base. So always keep track of what the base is and what's the inside of the log is. Okay? Now in this problem, I give you 3 logs. And to use the equivalency property, you need to have 1 log on either side of the equality. So what do you think we should do? I could recommend moving one to the other side, but that's not really going to solve your problem. You're just moving it from one side to the other. It's just going to flip positive and negative, positive and negative. You're not really getting rid of it. This is where we use some of the properties in the previous section. So before, with exponential, when we use logs, I used the power property, where if you had a power, it comes outside. But we also had an addition and a subtraction property, right? So 1 was a multiplication. What did it do? So the product property said that if you had 2 logs added, that means that you can technically have those 2 together in 1 log. Sorry, 2 logs multiplied. That means you can have 2 logs multiplied to each other. In this one, we have a subtraction. The other property, which was the quotient property, said that you had 2 logs with subtraction in the middle. That means you can write these 2 as 1 log with these 2 values divided by each other. Now, in the first one, the product property one, it didn't matter the order, because when you're adding or multiplying, the result is always going to be the same if you flip them, right? But with this one, the second one, the one that's negative, is on the bottom. It's always on the bottom. So again, this is a review from the previous section. Now, I have 2 logs subtracting from each other, so I'm going to write these as 1 log. Like that. Okay, so first one goes on top. Second one goes on the bottom. This is the quotient property. So now I rewrote these 2 as 1 log. It equals log of 2. Base 10, base 10. They're both base 10. So that means now I can take the inside's log and solve. So the inside of this one is 3x minus 4 over x plus 1. And the inside of that one is just a 2. Yeah? Now from here, I need to find x. So the easiest way to get rid of it is to get rid of the complication I have right here, which is the x plus 1. So I'm going to multiply by x plus 1 on both sides. These cancel, and here you have 2 times x plus 1. So 3x minus 4, which is the top, equals 2 times x plus 2. Now, combine likes, so 2x goes here, and the negative 4 goes here. This turns negative, and the result is just an x. This turns positive, and the addition gives you 6. Again, That's actually kind of funny. 3 problems in a row. They're all 6. Now, the answers stick. It's 6. Here we go. So, now I need to check. Don't forget to check. So I'm checking 6. Question. Where do I plug it in? Here? The one I rewrote and then solved? Or here? The one the question gave me? You write it in the one the question gave you. Always. This is what I was talking about earlier. The one that was actually typed in front of you. Right? The one the exam gave you. Forget everything else. This is the one you plug into. Because if you plug in here, it often happens that it works out when it's not supposed to. Make sense? So always plug in the one the question gives you. Now in this case, they're both gonna work out, so we're good. So if you plug in the 6 in here, you're gonna get what? 3 times 6, which is 18, minus 4, that's 14. Log of 14 is a positive number, we're good. Over here, 6 plus 1, log of 7. Log of 7, no problem. And over here we have log of 2. This is subtracted. You can move it if you want to make an addition, but it doesn't matter. You can add those. It's fine. Actually, if you move this right here, move it to that side. Let me write it down so you can see the result. If you want to do this by hand, you're welcome to do it by calculator. This is for the people who might forget their calculator or didn't buy one, right? If you don't have one of these and you want to do this by hand, the check. So the first one we plugged in the 6 in here and it gave you log of 14, right? Okay. And the second one is negative log of 7. And it equals log of 2. Okay. Now, you can move this log right here, the negative one, to the opposite side. And this will give you log of 17 equals log of 2 plus log of 7, because it turned positive, right? Okay. And the product property said 2 logs added are actually the same log with the 2 values multiplied. So it's 2 times the 7. Over here we have log of 14. 2 times 7 is 14. So as you can see, both sides are actually the same. Another way, you don't have to move this. You can undo this one. So 14 is 7 times 2. So you can split it into log of 2 and log of 7. And then you subtract the log of 7 from the positive log of 7 and you end up with log of 2 equals log of 2. Same thing. So this is if you didn't want to use a calculator. You're welcome to. You can use your calculator. Here. So we have log of 14. You have an answer for that? Yep. Okay. Oops. Nice. Backtrack. Log of 7. Do you have an answer for that one? And log of 2. Do you have an answer for that? Yep. Okay. Now, log of 14 minus log of 7. Here's my answer. It's 0.30, right? And a bunch of other numbers. Now, to make sure they're actually identical, I'm going to use answer, right? To see if it equals log of 2, I'm going to subtract log of 2 from it. And if the result is 0, that means we got it right? Oops. Boom. Yeah? And if you don't want to do that, you can just compare values on paper. It's up to you. But anyway. So, that was this problem. I'm going to give you guys a sec to copy. So, next I'm going to do number 12. Alright. Here we go. Now, in this question, we have natural log, so we're switching a little bit. Here we go. X plus 3. So natural log of x plus 3 plus natural log of 3. Oh, sorry. Natural log of x. Now please pay attention to this problem because I'm actually going to include something that looks kind of like this on the test. I did in the previous 2 years. Probably will this year too. And I'm talking about your final, not just exam 3. Okay, so natural log x plus 3, natural log of x, and it equals natural log of a number. So this is very similar to what we just did. But in that one we had subtraction, this one we have addition, so we're going to use the product property. It's natural log of the inside of the log multiplied. So it's going to be x times x plus 3. Like that. And the reason I wrote this one first is because it's easier. But it's up to you. Yeah? So there we go. Multiplied them inside the natural log. And it equals natural log of 10. Now, I have equality. One log on the other side. Both logs are identical. Same base, same everything. Just the inside is different. So I'm just going to grab the inside and set them equal to each other. We have x times x plus 3 equals 10. Yeah? Okay. Now, I'm going to multiply the x in. We get x squared plus 3x equals 10. And move this 10 in here. So that's x squared plus 3x minus 10 equals 0. Okay? Now, factor. X goes here, x goes here. You're welcome to use the quadratic equation if you want. So anyway, we have a negative multiplication result. That means one of them is going to be positive, the other is negative. And we have a 10. So that's either 1 and 10 or 5 and 2. And since the result here is 3, that tells you it's probably 5 and 2. Now, since the 3 is positive, that tells me that it's positive 5 and the negative 2. So it's x plus 5 and x minus 2. Now, I'm going to solve for each x. It's going to be x equals negative 5 and positive 2. Alright? Now, I need to check both of them. Let's check the negative 5 because it kind of looks suspicious. So let's check this one first. Okay, again, do I do it here or do I do it here? I'm going to do it in the one the question gave you. Now, let me demonstrate why we don't do it here. Okay, here's my calculator. The number I'm plugging in is negative 5, yes? So, it's a natural log of negative 5. It's right here. In case you're using a calculator, you can't see it. Okay, this is a negative 1. Anyway, so negative 5 times negative 5 plus 3. So we already know the result of this addition is going to be what? Negative. And it's going to get multiplied by another negative. So the result is going to be positive. Yeah? Giving you an answer. The answer being 2.30258 blah blah blah. Right? Which is actually equals to natural log of 10. Because subtraction between the two gives you 0. So this checks out. If I plug the negative 5 in here, my check would fail because I would see that the negative 5 works. It didn't really help me. I want you to always use the question, not what you worked out. Now, if I do it in the question, you're going to have two separate negative values in two separate logs. Make sense? So in this one, if you plug in the negative 5 in here, it becomes negative 5 plus 3, which is negative 2. And natural log of negative 2 is an error. And if you haven't guessed it, the natural log of negative 5 alone, because this is just x, is also an error. So, negative 5 is not a solution. Okay? Now let's try the 2. Here you go. 2 plus 3, so 5. There's an answer. We're good. Okay. Now, just a 2. We're good. And since it's multiplication, if I multiply these two together, it gives you a natural log of 10. But if you want to compare, here we go. Oops. We have log 5 plus ln of 2, giving me this number, which is 2.30258, the same number we just saw. And if I subtract natural log of 10, the difference is going to be 0. So it's the same answer. So while negative 5 failed, 2 succeeded. It passed. So this is your answer. Only the 2. Okay? So please write that in your notes. Always check in the form the question gives you. Not what you solve. Okay? Better yet, when you want to check, look back to the exam, not where you're solving, not your work. That's the line that was actually typed. So look at the screen and go, okay, that's what I'm checking into. Not this. Alright? Okay. Now, let me do one more. Oh, that's actually kind of similar. Alright, let's switch it up a little. Okay, I'm going to move on to number 14. Okay, so for this one, before I solve it, I want to show you a constant rule. So the constant rule says that if you have a log base b of x, so x is the inside and it equals k, right? Then x equals b to the k, where k is constant. And that kind of makes sense, right? Because we said that the base of the log is the base of the exponential, the answer of the log is the power of the exponential, and x is the inside of the exponential is the answer of the the inside of the log is the answer to the exponential, right? So we already know the setup. The difference here is I want you to note that I'm using a constant k. It's not just another value, it's not y, it's a constant. Now the reason this rule is helpful, because it would save you having to go through the trouble of actually doing the equivalence property we've been using. Let me show you an example. If I give you log to the base of 5, okay? Log base 5 of 3x plus 1, and it equals 2. Yeah? Now, this property says this log base b of x equals k. So since the log equals a number, not another log, I didn't give you another log, I just gave you a number. Okay? So if it equals a number, then I'm going to convert it back to exponential. And notice, this is technically kind of the same thing we did for the exponentials when we couldn't solve it. So what did I do? We had exponential and just a number on the other side. I took log of both. I flipped it to log. Well, now we're getting rid of the log and flipping it back to exponential. Okay, so for this one, log base 5 of 3x plus 1 and it equals 2. So to convert it back to the exponential, the x is going to be, which is the inside of the log, right? So it's 3x plus 1. It's going to be on one side. I'm going to write it like this. Convert, right? So it's 3x plus 1, which is the inside of the log. And it equals the base, which is 5, to the power of the answer, which is 2. See what I did there? Now we have what? 3x plus 1 equals 5 to the second power is 25. Right? So 1 gets moved to that side, it turns negative, and we have 3x equaling 24. Divide by 3, and x is 8. So while it made it look complicated for the exponentials, it's actually simplifying things for the logs. So this is actually a cool trick. If I give you an inequality that has logs, and instead of giving you one log on either side of the equality like we've seen so far, and instead I give you just a number, then use this trick. Okay? Let me do this so you can read it one more time. I'll give you a few seconds. So let's move on. Alright, now. Okay. I'll do number 15. This question says you have log base 3 of x plus 6 minus log base 3 of x minus 2, and the whole thing equals 2. So I have logs on one side and a number on the other side. And here's a question I got before. Oops. Man, I need to drop the camera. Alright. So here's a question I got before. Can't I just move this to the side and I'll have a log on either side? It's like, yes, but you still have a 2, and that would be kind of difficult to deal with. Instead, keep both logs on this side so you can deal with it using this neat trick. And since we only need to use one log, and like you have to have only one log on this side, I'm gonna combine these two logs because I have subtraction here. So using the quotient property, subtraction between two logs of the same base means that you're just gonna have one log with the inside of the first one on top and the inside of the second one on the bottom. So I'm gonna rewrite this to be log base 3 of x plus 6 over x minus 2. And it equals 2. Now I can use my trick. So the trick says the inside of the log, which is x plus 6 over x minus 2, equals the base of the log, which is 3 to the power of the answer. So this fraction equals 3 to the second power, which equals 9, right? And now we need to solve for x. So first step you need to do is get rid of the bottom. Easiest way is to multiply both sides by x minus 2. So we have x minus 2 on this side, these cancel, x minus 2 on this side, and you have x plus 6 equals 9 times x minus 2. I'm going to multiply the 9 in, and that's 9x minus 18. And on this side we have x plus 6. Yes? Now, I'm going to move the x to this side, move the 18 to that side. So, the 18 being moved here, 18 plus 6, that gives you 24. And over here we have 8x. Divide by 8, divide by 8, and x equals 3. Okay. Now, let me do one more. And I'll do 17. No, actually, I have a better idea. I'm going to do 16 and give you guys 17 as a bonus on your upcoming exam. How's that? So if you do question 17 in the notes, yeah? Question 17. If you solve this one, I will give you 3 points on your exam. Exam 3. Actually, make it 5. 5 points on your exam 3. Alright? And this is for anyone who submits it correctly. Okay, so number 17 is a bonus question for your exam 3. Now, please note that if you're one of those students who don't watch the video and just pretend that you do, you won't even hear about this because I won't be posting an announcement. And please don't tell each other. That we all know. But yes, so question 17, if you solve that one, I will give you 5 bonus points on your exam 3, and the way to submit it would be through the assignment for this video. So after you finish watching both videos, before you click submit for the assignment, I want you to actually upload a picture or scanned copy of the page you solved the problem on. Okay? And it doesn't have to be a scan if you don't have a scanner, just a picture is fine. Just make sure it's clear enough for me to read and it has your name on it. Okay? Name and section number, so I'll know which class you're in. Alright? So, now let's do number 16, and we'll be done with this section. Okay, here we go. So the question says, log of x plus 15 equals 2 minus log of x. Now, I have 2 logs, and I see no base. What does that mean? It's base 10, right? Okay. Now, I have 2 minus a log, so a number minus log. That actually complicates things. So the easier way to solve this would be to move the log to this side. So I'm going to get log of x plus 15 plus log of x. And the whole thing equals 2. Now, 2 logs with an addition in the middle. Both logs having the same base. What does that tell you? I'm going to use the product property. And these 2 logs gets combined into 1. So it's going to be x times x plus 15. Like that. And on this side, we still have the 2. Okay, now, our little trick says, inside of the log, so x times x plus 15, equals base of the log, it's not written, but we know it's 10 to the power of the answer, which is 2. So that means it's 100. Okay, so now on this side, I'm going to multiply the x in, like this. So you have x squared plus 15x equals 100. Now, move the 100 to this side. And now we have a quadratic. Right? You can factor. And if you don't want to factor, feel free to use the quadratic formula. Whatever works for you. Okay, so x goes here, x goes here. There are a few combinations that could give you 100. But remember, the multiplication is 100, but the addition is 15. So if you, for example, use 2 and 50, when you subtract those two, it's not going to give you 15. No way. If you use 5 and 20, now that would work, because when you subtract 5 from 20, it gives you 15. So since it's negative, one's positive, one is negative. And since the 15 is positive, that means the result of the addition was positive, meaning that the 20 is the positive one and the 5 is the negative one. Yeah? So, solving for these, you move it to the other side, kind of like what we did with the synthetic. X is negative 20, flip the sign, and positive 5. Okay? So those are my answers. Now again, always check. Now I didn't check in the previous problem because I already knew the answer was going to be right. But let's check for this one too. I'm going to go, oh, actually you're not going to be able to see the answer. So I'm going to write right here, x equals negative 20 and positive 5. Okay, so you can see it. So this is where I'm plugging in. The form the question gave you, with the 2 minus the log and everything. This is the one we're using. Okay, now let's plug these numbers in. Now, negative 20, if you plug it in here, it's going to be negative 20 plus 15. That's a negative 5 inside the log. Error. That's a problem. in here, log of negative 20. That's a problem. So we have an issue with both logs. Negative 20 is not going to work. What about the 5? 5 plus 15, that's 20. And over here is just negative, but log of 5. So it's a positive log. Just the sign on the outside is negative. And that's fine. So that works. 5 works. Now let's check if that's actually the answer. Here we go. So log of 20. Here's the answer, right? Now, actually, I have a better idea. 2 minus log of 5. It gave me an answer. That means that the negative log of 5 is fine. Now, minus log of 20. If both these sides are the same, the subtraction between the two is supposed to give you 0. Yeah? So 5 checks out. 5's okay. So even though the question gave you 2 answers, negative 20 was not an acceptable solution, but 5 was. Alright? Now, I've been moving too quickly. I just want to make sure you guys got a chance to copy this. So I'm going to stop for a sec. Like this. So you can pause the video and copy this. And now I'm going to move up a little bit so you can get the rest of it. Alright. So, in case you didn't get a chance to look at the notes or you just don't want to, I don't know. I'm just going to write the bonus question right here. Here we go. It's log base 4, okay, of x squared minus 9 minus 3. Okay, so the minus 3 is on the outside of the parentheses. Now, equals log base 4 of x plus 3. Okay, this is the question. If you solve this, you get 5 points. Oops, bonus 5 on E3. And here's the fun part. This is due along with the videos. So since these videos are due on Sunday, because I want you to submit the solution with it, this is also due on Sunday by 11:59 p.m. Okay? So you only have until then. After that date passes, I will upload the solution to the section. Alright? So here's a question. 5 points on your exam, and you have until Sunday at 11:59 p.m. And I just want you to upload the page, attach the page of this solution or a picture of it to the assignment where I usually post the videos to make sure you guys saw them. Okay? That's all. Alright? See you in the next session.